Hi fellows, and welcome to my YouTube channel for Landrover Defender. In this video we'll be talking about the TD5 ECU, and more specific, the vital signs. Now the ECU stands for Engine Control Unit, and its prime role is to manage and control and drive the engine, control the power of the engine. That's its main role. It has some other side roles, but its main function is to actually control the engine. And it controls the engine through sending pulses towards the injectors, because the ECU will determine how much fuel and at what time it's going to be delivered to the cylinders. Now the injectors themselves are like mini fuel pumps. There is a mechanical mechanism on top of every injector that will pressurize the diesel fuel. But it will not inject it into the cylinder until the moment that the ECU has sent that pulse width modulation signal to each of these individual injectors. Now the pulse width modulation signal is going to change in time and shape, and that will determine how much fuel will be injected, in what way, and how much. Now, an injector in the TD5 works basically in multiple stages. There is a first stage whereby fuel is injected into the cylinder. That fuel then starts to burn, and then additional squirts of fuel are injected into the cylinder, because now that the gas is already burning, when you inject even more, you have even a more explosive force that happens inside, and that you will see on additional pulses on the waveform in a few minutes when I'm about to show you that. Now the ECU doesn't do this by itself. It needs something what we call a demand, and the demand, that is us. When we drive the Defender and we press down the gas pedal, then we are sending a signal to the ECU, and that signal, I call that a vital sign, tells the ECU, I need to speed up, I need to produce more power. So the ECU then kicks in action. It will look at a whole bunch of other parameters that are around the car. For instance, the manifold pressure, the airflow, the ambient temperature, the engine temperature, the fuel temperature, the position of the crankshaft, all very important parameters or vital signs for the ECU to make the right decision as of how much fuel should it inject into each cylinder, and how should my pulse width word be modulated. Now, to do so, the ECU uses a three-dimensional fuel map, and you might have heard the word fuel map, but a fuel map is nothing more than an output given on a whole raft of input parameters. We already talked about the vital signs of incoming parameters, the gas pedal and the MAF and the map, RPMs and top dead center sensor, the crankshaft sensor basically, temperature sensors. All these are critical signs that are fed into the ECU, and the ECU will calculate some of those, and it will then look into the fuel map on the matching point, and then it will read out basically what amount of fuel it should inject and at what time. And then it creates this command or this pulse width modulation pulse that's been sent on an individual wire to each of those injectors. And that's what it does. Now, there are some very critical signs on the vehicle. For instance, top dead center. That is a very important critical sign, because the ECU needs to know when to inject the fuel, when to send the word, because if it doesn't, then it's not going to work. So if you're missing the top dead center signal as an incoming signal to the ECU, then the car is not even going to start. So just think about it for a minute. The engine is cold, you get in your car, you put the ignition key on, first position ignition, you have some lights that come up. These lights are driven by the ECU. Meanwhile, the ECU has gotten its powered, it's started up, and it's ready. But it hasn't done nothing, really. It doesn't even know where the crankshaft is. So then you turn on, and then the starter kicks in, and the starter starts rotating the engine. Now, as soon as the engine starts to rotate, now the ECU starts seeing the top dead center. Now it starts knowing where the crankshaft is, and only now it can actually inject fuel into the cylinders by sending this control word to the injectors. And that's how it works. And now the injector gets the control work, it injects fuel, the fuel will ignite, and now the engine starts to run. We let go the ignition key basically, so the starter stops, and now the engine is running on its own. And of course now, when the engine is running on its own, it's idling, and the ECU is responsible to keep it on an idle speed. So it has to keep on injecting fuel in the proper amount. But be aware that the temperature of the car was very low when we started because it was sitting outside maybe. But while the car is idling for a while, temperature goes up, fuel temperature goes up, everything goes up a bit. So these are changing input signals, changing vital signs for the ECU. So the ECU will automatically adjust these keywords or control words towards the injectors. It will vary that a little bit in time and in shape so that we maintain a proper RPM in idle. And this is a bit how it works. There's a lot more to it, but these are the vital signs, and I will get more into this in another video. But now it's time to look at a few things, because troubleshooting this whole mechanism is very hard, and a lot of people believe that their ECUs are bad, where they are not bad. You can see that this whole mechanism is a bit complex because it's kind of a closed loop. You have input signals, these are output signals driving the engine, but when you drive the engine, the input signals will change, right? So everything is like a variable, and it all interworks. So if you have a sensor that is not working properly, maybe you have a faulty airflow sensor. Well, then the ECU won't read something proper, and it will not dose the amount of fuel correctly or in the most efficient way. The same thing is true for other sensors. Now, some of the input signals are very critical. Others are less critical. For instance, the airflow sensor, if that is faulty, the car will still drive, not optimum, but you can still drive it because the ECU will default to a standard value. Now, other aspects of the ECU are the fact that it takes care of the environmental conditions by opening up your Egr valve. And it does that also, again, based on how much power is demanded. If there's no power demanded, then it's going to open up that Egr valve so that you can recycle exhaust fumes into the intake manifold, thereby reducing the amount of oxygen in the intake manifold and lowering the combustion or explosiveness of that mixture into the cylinder and reducing the power. And if you do that, then you reduce the NOx gases in the exhaust. And that's a bit how that works. But as soon as you then depress the throttle, then the ECU knows I need power now, so then it shuts off the Egr valve, and then the whole thing takes place again as I described before. All very interesting. Now the question now is, how can you check all this? And what should you check? Well, it is my opinion that you should check the vital signs, the most critical ones. And then you can also check the other less critical vital signs with a data logger. Because some of these issues, you need to see it over time. You cannot see it always on the spot. So you have to start logging that data in one way or another. But that's in my next video on how to log the vital signs. Right now, we will be looking at the top dead center marker or the crankshaft sensor. We'll be looking at some of the pulse widths, and then we'll see how these things go. Now, where is the ECU? That's a quite common question. The ECU in the TD5 is sitting on the right-hand side underneath the seat. Now, if you live in the UK or in Australia, that's underneath the driver's seat. If you live in Europe, that's under the passenger seat. But it's always on the right-hand side. So let's have a look how that looks like. So this is the ECU of the Landrover Defender TD5. It's fitted on the right-hand side underneath the seat, and it has two connectors, a red one and a black one. And then you have a whole bunch of wires that connect to these connectors. If you need to know what wire is what, then you need to look it up in your workshop manual. So finding out the right pins on the ECU and the connector is very easy if you have the electrical diagram of your vehicle. In this case, it's a TD5, and you just have the Haynes workshop manual. It's good enough. And On the diagram, you will find all the wires. The colors of the wires are identified and the legend is on the top. And for instance, the points we will be checking is the first injector lead and the crankshaft positioning sensor. Now, all what you have to do is actually follow the lead on the diagram, find out what is the color of the wire, what's the pin on the connector on the ECU, and then use some of those test leads like I have over here, and then we'll just slide that in along the cable into the connector, and it will make contact if the pins are long enough. So that's quite easy. And then the other side, you just need to connect it up to your probe of your oscilloscope. Now you will need an oscilloscope to measure this kind of signals. You can't do this with a normal voltmeter because they're changing too fast. Those are pulses and you can't see it. So you need to have a visual indication. I have here a very cheap oscilloscope, a single channel, and you can get this for about 60-70 euros, and it's quite handy, and you can use it for all kind of purposes on your vehicle. So this is what we're going to do. Now for the demonstration I'm going to give you, I will use a laptop-based scope because the screen is a bit too small to show you on a video what all the results are of the measurements. But this is the point, guys. There is a lot of input signals coming in the ECU, and then the main outputs are actually the outputs towards the injectors. And it's so important to measure those vital signs on the ECU if you think you have problems with the ECU, or you have problems in general with the performance or the behavior of the engine. You know, there's a lot of things you really can do. So now let us get on with it and start working on actually measuring, first of all, the injector pulses and one vital sign which is coming in, which is the crankshaft positioning sensor, which is over here feeding into the ECU. We will be watching those 2 points and making sure that they line up and that everything is working fine. So I looked it up, and the full yellow wire, which is this one right here, that is the wire which is going to the first injector, and that will carry the code or the pulse for the injector to inject the fuel. So we're going to put that wire onto a trace on an oscilloscope so you can actually see the pulse. An oscilloscope, and I have one here, and this is a very small one, is good enough, and this doesn't cost you that much money. It costs you probably around 70 euros, and you can use that to actually look at pulses that are coming out of the ECU. You will need to attach a probe to it, and then you attach it, and the way you attach it is very simple. You can use these small little test cables, you can get them in an electronics store, and just slide it in next to the wire into the hole of the connector, like so. And I've done that now on the first cylinder, and I also already have a ground cable connected as well, which is the little black one on these black cables. That's the ground. And I also have the top dead center already plugged up, which is a purple black wire, and I traced it down already, and that's what we'll be looking at in a few minutes. So first let's have a look on how that signal looks like when the ECU is talking to the first injector. Of course the car is not running now, but let me hook up the kit and then you'll see it. So the first thing we'll do is hook up the probe, and we'll attach the probe to the signal lead, and this is the signal lead that goes to the first cylinder. We hook that up, make sure you make no shorts, and then we'll hook up the ground as well, because that's very important that we have a common ground. And then we'll crank up the engine and see what it does. Now we'll crank it up. So here you can see the pulses are being sent to the injector, but I'll change the timeline a bit so you will even see it better. So here you can actually see the pulses that are being generated, and these are the pulses that are going to the injector. Now let's have a look on the other pulse, which is the crankshaft positioning pulse. So now we are measuring the crankshaft positioning pulse, so the pulse coming from the sensor, and basically it shows top dead center every time. And because the crankshaft is rotating, you have multiple pulses. If you don't see this, then you really have a problem with your top dead center sensor or your crankshaft sensor. It's the same thing. So this is really a handy little tool to make sure that the vital signs coming from the sensor are actually arriving on your ECU. Now, if you have the top dead center markers coming in on your ECU and you can measure it, and you do not measure the proper output, or you don't measure any output towards the injectors as I shown you before, then the ECU really has a problem. Or one of the other sensors is having a problem. If you don't see these pulses coming from your crankshaft sensor, then either the sensor is bad or the cabling is bad, and this is how you can diagnose it. We hooked up the probes to the crankshaft positioning sensor and the first cylinder for the injection. So we hooked up the probes to an oscilloscope, and we're showing two traces. The top trace, or the blue trace, is the trace that shows the top dead center of the crankshaft positioning sensor input to the ECU. And the second trace on the bottom, the yellow trace, is the signal that goes to the first injector. And you will see that they will be spaced over time, but the more throttle I give, or the more RPMs the engine starts to make, you will see that these pulses are getting closer to each other. Now, right now you don't see nothing because the engine is not running. So let's have a look. So we'll crank up the engine and keep an eye on the oscilloscope. And as you notice, we have the blue trace showing now the crankshaft positioning sensor input signal to the ECU, and on the bottom we have an output signal which is going to the first injector. If we speed up the engine, or we push down the throttle, then you will notice that these pulses will get closer to each other. So keep a close eye on the pulses, the distance between the pulses. And that's exactly what should happen with the unit. So this is a very good indication that the signals going to the injectors are working properly. So fellows, you've seen how you actually can measure the signals on the plugs on the ECU. We only looked at two vital signs. We looked at the vital sign, which is the input signal coming from the crankshaft positioning sensor, which is very important, which is the top line, as you can see. And then we looked also as well at an output signal of the ECU, which is driving the first injector solenoid, which is the yellow line. And guess what? Both of them line up. And obviously that's quite normal, because the white line is what we call the top dead center of the first cylinder, and obviously the injection has to take place at that moment in time. You see some alterations on the pulses there, but that's quite normal because the sensor has more sample points than just one. And of course, if you're looking at the injector itself, you see that the behavior is a bit special on that one, on that pulse, and that's also quite normal because the injectors will do kind of a pre-injection and then they do the final injections, as I explained before. And this is what you could do. You could go and check every single line that goes to a injector with a single scope, oscilloscope, as I've shown you. Make sure you don't make any shorts, and then you should see always the proper pulses coming up. If you don't, then you know that the ECU is having potentially a problem. But if you see the vital signs coming in, like so, like on the top one, the vital signs, meaning in this case the crankshaft positioning trace, and if you also then would double check the pedal, the gas pedal trace, that's also a signal that which is incoming to the ECU, then you can easily find out what the problem is. Similarly, you can take traces of the air temperature sensor, you can take the traces of the map, the engine temperature, and so on. You can do all that and log it on the scope and see. If you don't see signals incoming from those sensors, then you know something is wrong with either the sensor or the wire, and it's not a problem of the ECU. So this is how all this is working. I will show you in another video how I'm logging longer term vital signs from 4 different sensors at the same time, and therefore we'll use a little data logger, which is another 50 euros, a piece of kit that you can attach to your laptop or your tablet. And the last thing I would like to talk to you is about the fuel map. If people talk about chipping the ECU or modifying the fuel map to make it more performant, all what they mean is actually going to modify the yellow line. They will modify the shape of the pulse here so that the injector injects a bit more, a bit less, a bit earlier, a bit later, all depending where you want to have the power and the torque. And that's all depending of the vital signs that are incoming to the engine, and that's what this is all about. I hope you enjoyed this video. It maybe was a bit technical, but I think I was trying to bring you the message across that if you want to troubleshoot your vehicle and you have problems with performance on the engine, don't rip out the ECU immediately. Make sure that all the vital signs that are coming in from all the sensors are correct and are there and are changing, and check also as well the signals going to the injectors. Now, of course, if the signals are going to the injectors are proper and the engine still doesn't run proper, you still don't have the power, maybe you have a mechanical problem on the injector itself, and then you need to check on that part. So thank you for viewing, and I'll see you on my next video.